you should at least realize when you should look at polar form. The great advantage of polar form is particularly once you've mastered the exponential law, the great advantage of polar form is it's good for multiplication. Now, of course, you know how to multiply complex numbers even when they're in the Cartesian form. You know, that's the first thing you learn in high school, how to multiply a plus bi times c plus di. But as you'll see, when push comes to shove, you'll see this very clearly on Friday, and that's, Friday, when we talk about trigonometric inputs to differential equations, that the changing to complex numbers makes all sorts of things easy to calculate, and the answers come out extremely clear, whereas if we had to do it any other way, it's a lot more work, and worst of all, when you finally slog through to the end, you feel you're none the wiser. Those are two things definitely to be avoided. So it's sort of funny, I'm sort of interposing this lecture. Why is he suddenly starting to talk about complex numbers? And so I ask you delayed gratification. You won't ask me on Friday. You'll say, oh, thank you, Professor Maddock, for teaching us about complex numbers and polar representation. Gifts will be humbly accepted. Well, no, not really. Okay. It's good for multiplication because the product of so here's any number in its polar form. That's a general complex number. It's modulus times the e to the I theta times R2 e to the I theta 2. Well, you just multiply them as ordinary numbers. So the part out front will be R1, R2, and the e to the I theta parts gets multiplied by the exponential law and becomes e to the I theta 1 plus theta 2, which makes very clear that to multiply geometrically two complex numbers, you multiply the moduli, the r's, the absolute values, how long the arrow is from 0 to the complex number, multiply the moduli, and add the argument. So the new number, its modulus is the product of R1 and R2, and its argument, its angle, polar angle, is the sum of the old two angles. And you add the angles. And you put down in your books angles, but I'm being photographed, so I'm going to write arguments. In other words, it makes the geometric content of multiplication clear in a sense in which this is extremely unclear. From this law, you know, blah, 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 whatever it turns out to be, you have not the slightest intuition that this is true about the complex numbers. It's that first thing is just a formula, whereas this thing is an insightful representation of complex multiplication.